So here the potential energy was already there and which has converted to kinetic energy. So energy was not created, neither it is destroyed. So whichever is the energy, whatever is there in that rest part was moved to the kinetic energy. So whatever lost we represent in a negative way, which is with the negative symbol. Whatever is gaining we represent as a positive. So PE is potential energy and KE is the kinetic energy we represent by a negative symbol. So PE plus KE equal to 0. It means the potential energy plus kinetic energy equal to 0, which is nothing but a constant. Okay. So now you understood that there is a conservation of energy. Conservation means retain. We are retaining. We are not creating. We are not either destroying, right? The matter was having earlier energy when it is at rest, and again it attained the kinetic energy when it is started moving. The example of conservation of energy is, for example, how can you see a bulb having so much of emitting lights? The electricity which is having an energy has converted to a light energy. Because of that, you can see a light in a bulb. Similarly, how do you hear radio? The sound energy has been converted, or electric energy has been converted to the sound energy, right? There is nothing actually generated, it is just transformed from one form to another form. Now let's understand what is the law of conservation of linear momentum. To understand this better, let's take the two small balls. The ball 1 is having a mass m1, the ball 2 is having a mass m2. The initial velocity of ball m1 is u1 and the initial velocity of ball m2 is u2. The momentum between the collision of these two balls equal to the momentum after the collision. So the two balls were having m1 m2, initial u1 u2 velocity, they are colliding each other and they will attain the velocity of v1 and v2 respectively. So after collision, what happens is the velocity from u1 it changed to v1 and u2 it changed to v2. Hence, the momentum before collision is equal to the momentum after collision. With that, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. So here we did not change the mass because there is no change in a mass at all, only there was a change in a velocity and momentum. Okay. So example of this linear motion is the carom. When we are playing a carom, right, the coin, actually the energy from our hand just strikes that particular coin, right, the particular potential energy would change to the kinetic energy, and energy exerted by us is equal to energy generated post the collision. So this is an example of the conservation of energy on a linear motion. Now let's understand what is the conservation of energy in a circular motion. The circular motion is nothing but when the object is moving on the peripheral of a circle, we call it as the circular motion. When object is moving at the peripheral or circumference of a circle, there are two forces exerted on that object. One is a centripetal force, the second one is a centrifugal force. The centripetal force exerted on that particular object while object is moving in a circle is moving towards the center of a circle. The centrifugal force is actually pushing that particular object against the center of a circle. Because these two forces are equal, the object is moving around the peripheral of a circle with an equidistance and with